All right, Wiz, you ready to fold some context today, dude?
Couldn't be more ready.
So RLMs. Everybody is talking about it. A lot of people asked us to cover this. Are they truly brand new? And we should all know about them, and we should all be using them today.
They are brand new. I mean, in the sense that the term and the paper are recent, yes. I think the core ideas of RLMs are new is I think a silly word to index on, but they're certainly it's a formalization of some existing ideas. Let's say that.
Another step along the steady drumbeat of progress with LLMs, with agents. So we're going to see some recursive action today, some looping back in, some context folding. It does feel like this is a little bit of the future of context engineering, though. Is that fair to say?
I don't know if it's the future of context engineering, but I do know that it's an interesting tool in the tool belt of context engineering. Absolutely. Okay. We should think of it as yet another tool, but it's not like we shouldn't hope for a one size fits all, solution to context, to the big beast that is context engineering.
It's another tool rather than another type of LLM.
That's correct.
I like the way that we can think about this. And you've got two demos for us today to show us how to run RLMs in two different ways. I'm pretty pumped about it. Let's not tell everybody exactly what that's going to be, but it makes sense to show two different ways, doesn't it?
100%. It's it's like the raw version versus like the buttoned up clean version that we're gonna see today. And
okay.
And I mean, spoiler alert, I like the buttoned up clean version a lot.
Yeah, spoiler alert. We're gonna see some names we know well on this channel today that they've got their hands in the cookie jar of RLMs.
That's right.
Man, I'm excited to kick this one off. You ready to go, Wiz?
Couldn't be more ready.
All right, let's go ahead and get this thing going. We'll see you back for the demo and some discussions along the way. Welcome, everybody, to Recursive Language Models. If you got questions along the way, you know what to do. Smash the chat. Let us know. Jump into the discussion. We've got quite a bit of background to cover, and hopefully you walk away from this next hour as we align ourselves to the sesh here, understanding what RLMs are, what problem they solve, when we should use this idea that RLMs present us with in our applications. Let's understand how they relate to other context folding solutions. And of course, let's build, ship, and share with some ways we can do inference with RLMs. So let's get into it. All right. It's all about context, and it's really about the right context at the right time. So as we introduce RLMs, it's important to sort of put that into the appropriate context. All right, let's get into it. RLMs intro. The paper came out December 31st, 2025. And they proposed formally here this general inference strategy that treats long prompts as part of an external environment and allows the LLM to programmatically examine, decompose, and recursively call itself over snippets of the prompt. Okay. But where did this come from? Well, 2 months prior, 2.5, there was a blog released. Blogs always come before the paper. And we've got some simpler language here. We explore language models that recursively call themselves or other LLMs before providing a final answer. Okay, sick. Maybe we could back up even more just to put, again, this whole thing in context. Here's a tweet that came out the same day from the author, Alex. RLMs are meant to address context rot. Oh, okay. That's helpful. Because we've learned about context rot before. More context doesn't mean it's better. Performance starts to degrade as context gets longer. This was from the context rot work done originally by the Chroma DB team. And this kind of fun experiment they did where they basically said, yo, LLM, just replicate the following text exactly the same. Apple, 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 apples, apple, apple. Okay. And they did this with a bunch of words, a bunch of different kind of similar words, but kind of a similar pattern here. And what they saw is that no matter what kind of model you used, if you just told the LLM to say the same stuff over and over, that somewhere between like 100 and 1,000 input tokens, you're going to kind of degrade on some models, and definitely between 1,000 and 10,000, you're going to degrade even on the best models significantly. And, you kind of tell the LLM to say the same thing over and over, and you seriously get this weird brain rot, freaking out thing happening where you get this kind of random outputs that you didn't expect, which is probably the worst user experience. Okay, I'm going to take a break. Let me know I'm not in the mood. I need to chill out. Remember, he's supposed to be saying golden here. I'm going to go somewhere and get some fresh air, maybe to the beach or just chill out somewhere. Can't handle this anymore. Okay. And this is something that a lot of people were studying at the time. Context rot was sort of defined, came out July 18th. July 19th, the team, right at the same exact time, basically, the team from Manus put out a pretty sick blog called Context Engineering for Agents, Lessons from Building Manus. And they said, if your context is full of similar past action observation patterns, if we condense that all the way down to like, we're literally just telling you to say the same word over and over, the model will tend to follow that pattern. And the more uniform, the more brittle your agent becomes. So brittle, it might just snap and break. And this was kind of an observation in this paper, in this blog, where the big idea was that context is going to become long and we got to manage it. And there's a number of ways that they said we should manage this. Lessons that we've learned trying to manage our coding agent. And a couple of these are interesting, and they foreshadow some of the things that we need to talk about today. First of all, they said mask, don't remove. They said keep the wrong stuff in, meaning I did this thing wrong, but I fundamentally am able to learn from that mistake, that error. And so if I keep that mistake in my memory, so to speak, I'm going to not make the same stupid mistake in the future. And then this idea of using the file system as context got very popular and became a bit of a gold standard since that time. Okay, back to the tweets from Alex. What if scaling the context windows of frontier LLMs is much easier than it sounds? I'm listening. Okay. All right. We're all listening, Alex. RLMs are as general purpose as the underlying language model. In fact, from the perspective of the user or the builder using APIs, they look exactly the same. Language model, RLM. But they can internally spawn recursive calls. so we can get a better look at that. Here, they look same. And, but what's going on inside? Well, we can take a look at this. It turns out that the key here is the REPL Python notebook environment vibe. What is that? Well, a REPL environment is just an interactive development environment where you can type a line of code and you can see the result from the line of code that you typed. This loop of evaluate the code, print the result, read that result, go to the next. This looping is something that we're all familiar with if we've used any type of Python notebook environment at all. Essentially, anytime you're coding, can you see the output immediately in the same kind of space? And for those of us that have used plenty of Jupyter Notebook and Google Colab, we're all too familiar with this. This is not exactly the same experience we get in like a VS Code, where running and seeing the output have to kind of occur elsewhere. Of course, it's kind of, we can kind of see it, okay, with the command line in there. Jupyter Lab and Spider are a bit closer to VS Code. As long as we can see the output after we have an input, it kind of falls into this REPL vibe. What does that look like inside the RLM now? Well, let's look inside. It looks like we have this idea of this root LM output. We see this terminology, LM, feels so familiar for some reason. So we kind of have this root LM output, and then we get this thing that comes out of that. And we sort of keep all of this input, output stuff within our entire context window all along. And this is the big idea, okay? Why is it such a big deal, though? Like, really? Well, it's actually quite powerful, and it's far more general than any chunking strategy the team said when they released this. We argue that you should let the LLM itself decide how to best poke around, decompose, and recursively process the long prompt. Let the LLM itself decide. Bold strategy. We think RLMs trained explicitly to recursively reason are likely to represent the next milestone in general purpose inference time scaling after chain of thought style reasoning models and React style agent models. Welcome to the future. Thank you, Alex Zhang. Who's this other guy on here? Oh, if you notice that name, then you know that Omar is the OG of DSPI. He's been whipping out those new paradigms for years on X. He helped us move past prompt engineering, and he's been working on unifying prompting, fine-tuning, reasoning, RAG into a brand new paradigm where LLMs and their prompts fade into the background. Okay, all right. Seems actually pretty consistent. If you're wondering how to learn more about DSPI, check out our prompt optimization with DSPI event that we did just last month. Okay, Wiz, first discussion here. Hold on. So all we did is we just gave the LM Jupyter notebooks, and that's it?
Yeah. I mean, yeah. Like, yes.
Okay. What a banger idea. It
is a banger idea. I mean, the thing is it makes sense, right? Because we've had tools the whole time. So why not like have the LLM interact with the with the context exclusively through tools the whole time, right? Like it's not a, this is what I'm saying. It's not like a new idea. We've done this before. We use subagents to help do this. We do all kinds of things that kind of mirror this or exist in parallel to this pattern, right? But I do really think that this is a good paper that expresses explicitly that this is a good idea and then why it's a good idea. But yeah, we basically said people develop with Jupyter notebooks when they're looking at big swaths of data and it works great. What if the LLM just did that too? And then it was like, oh, it's banger, it works great.
Yeah. Well, we really like to sort of be able to see the code and read what comes out.
Yeah.
And then we're like, well, I mean, it's
like when I work with a data frame with 10 million rows, I'm never looking at all 10 million rows and like holding it in context, right? But like our data science has been crushing it without doing that the whole time. So what have they been doing? Okay. And what they've been doing is using REPL, right? Print a subset of the data, print me key statistics about the data, let me poke around in the data. Like all those things have been something we've just been doing the whole time. And like, of course, letting the LLM do that is way better than not, right?
The LLM is a data scientist now.
There you go. You know what? That's the headline.
Yeah. And by the way, it's not just Jupyter Notebook. Shout out to Manny. Okay, yeah. And I like him using the word harness here. We've got that one again. Let's go, Manny. It's not just Jupyter. It's anything, but that includes Jupyter. And like, hold on. Like, we'll come back to this, but like, we should let the LLM decide. Is this true? This feels a little bit, I don't know, uncomfortable if I'm an enterprise leader, even this statement.
Listen, I think what it comes down to with this whole, whatever you're going to call it, okay, I don't want to say the word paradigm.
Oh, I do. Yeah.
But like,
it's paradigmatic vibes today, 100%.
Again, this is something we've been doing the whole time, implicitly, right?
And when you say this, what do you mean exactly?
Just the idea that we should let tools scrape through context, right?
Okay.
Like when we talk about Claude code, or we talk about deep agents from LangChain or whatever, right? Like, and whenever we've given them a tool that says read file, right? Even this is, I don't know if we're even allowed to say this. I'm joking, of course we are. But even when we talk about building multi-agent systems in like our bootcamp, right? We build a tool that is all about reading files and editing files and looking at specific lines in files. Like that is the same pattern, right? Where we're using code to interact with some block of context. And we're allowing the LLM to make decisions exactly about what amount and how and what actions. And this is the same thing, right? It's just a much more cleanly presented version. And also, very importantly, I think it distills all of that stuffy thing that we were doing, which is like, oh, we're doing stuff. We're using tools to do stuff. I think it distills it into like one very focused concept, which is this idea that having this tight loop between LLM and REPL lets your LLM intelligently explore context. And what we talked about, which is something important as well, is it's not like the act of exploring context helps the LLM understand the context better, right? When the LLM says, I need to know how long this text is, and it does like print len text or whatever, right? Like it learns how big the text is, and that's going to inform future decisions about what it should do, right? When it looks at like the formatting of the document by taking a peek at different sections, right? It's learning about the document, and it's capturing those learnings so that it can better leverage the REPL to look at the context better. It's just like when I look at a data. I know I'm going to use this example a lot. Okay.
Yeah.
But when I look at a data frame the first time, and then you see like, oh well, how many of this column are nulls, right? And then you learn like almost all of them.
Yeah.
And you're like, oh damn, I've learned a big thing about this piece of data. And now when I'm thinking about interacting with the data in the future, I have this in mind. I have this loaded into context for when I need to make the next decision. This is something that is this is something that's really important, because it's not just like, here's a big chunk of context, have fun. It's like, explore this context and learn what the context is and how to best explore it, right, over time. And that's something that we haven't been thinking about as much, except for DSPI. Okay, obviously this is DSPI's whole thing.
Oh yeah, DSPI. That's right. Yeah, exactly.
So I'm not going to take it from DSPI, but like, I think as a broader industry, this idea that like interaction with the context is learning about the context is something that to me is a very important and fun part of this work.
Yeah. Okay. So we're basically going to use the LLM to derive insights from the data in classic data science fashion here. And I love the example of just print the len. Tell me how long this thing is. Some of the classic things you're going to do in the second or third block on your OG Jupyter notebook when you started learning data science.
That's right.
And so, and then moreover, it's not a new pattern necessarily, because when we give the LLM a tool, we say, here's the natural language description. You freaking decide. In fact, the decision making is the entire thing of agents. The idea that we let them decide stuff. So it shouldn't be as scary as it sounds.
And one point on that I just want to make sure is extra clear is like, imagine then we went one step further, right?
Okay. All right.
Imagine we have the RLM that's repled through our context, and it's learned the shape and feel of this context, similar to how a data science would, right? Or data scientist, sorry, would. Now imagine we like commit that to our memory somewhere, right? Like what this context is, what its shape is, what the feel is, so that the LM can reference that in the future.
That's right.
Right.
That's right.
Like this is the kind of next steps that take this from like I'm gonna do like the AI thing, right? Not just a context management framework, right? But like an actually extraordinarily useful tool for doing work, right? Like
intelligence.
Yeah, because if we can look at the context and then commit to memory what it is and how to explore it best, and what are the learnings we took, which we can do with the LLM, of course. That means the next time we do it much faster, right? Just like a data scientist. When we come back to the same pile of data that we were looking at on Wednesday, right? We don't have to go through all this nonsense. We've already done all that, right? We already kind of know the vibe. And so this work to me gives us really clear insight into what our next and you see labs like PI and stuff talking about this, right? What 2026 is going to be all about. So there you go.
Yeah. And by Wednesday, we've done some retrospective consolidation, actually sleeping on it, getting it back, and locking it in to our memory. Okay, Wiz.
We're sleeping on it.
Right? Yeah.
Okay.
The LMs be meta sleeping out here. Let's keep it rolling. Okay, the intro to RLMs, the new paradigm. Okay. What if scaling the context windows was much easier than it sounds? Indeed. Well, as Wiz just mentioned, PI, that's prime intellect. The day after the paper was released, on January 1st, what an epic day to ship, PI released Recursive Language Models, the paradigm of 2026. Just a quick note, shout out to both these two emerging legends here. Alex, who came up with this, working with the DSPI guy, and I believe, what's his name here? Sebastian over at Prime Intellect. Probably both worth a follow here in 2026 if you're into this stuff. Okay, let's take a look at the blog. LLM agents have become significantly more useful. They are now capable of implementing complex changes in large code bases autonomously, often reading and editing dozens of files, searching the web, and maintaining context even over the course of multiple such complex requests. These capabilities require huge numbers of tokens. Of course, there's context rot, which is not dope. But to address this issue, we see that a lot of things are happening. People are switching up architectures, they're changing up training data. We expect that all this will continue, models will get better, there's going to be tons of more progress in this space. Even with better models, what's a thing that we can do better to any model, no matter how good they get, to help solve this context rot problem? Answer: scaffolding. What? Turns out scaffolding is the stuff we need to basically put around our LLM for our build, right? It's no different than any other construction project. Claude Code, OpenAI's Codex, and similar text-based user interfaces tend to use file systems and context compression by summarization. File systems, summarization for their scaffolding. This leads effectively to a succession of agents, all connected to each other by a prompt and the state of some set of files. Remember, we should be using file systems as context. That's what Manus taught us. So before we dig into the details of the different methods, Wiz, I would just like to chat briefly with you about file systems and context compression. What are the pros and cons here of using a file system and summarization? Of course, if we extract the main idea and essential supporting details like SpongeBob here, we leave some stuff out. That's fundamental. What else jumps out to you as pros and cons worth mentioning here?
Compression is lossy, right? By necessity, effectively. Like we can get, like it's very, very difficult to construct situations where you get lossless compression. You can do so trivially, like file formats, right? You know what I mean? Like if you have 6 zeros in a row, you could say 6-0 instead of 0-0-0-0-0. But like when it comes to like dense unstructured data, it's very difficult to get lossless compression. So we are losing something. What we then have to make a value judgment on is what we're losing like important, right? And the word important here is something that we obviously need to defer to the LLM for.
Yeah.
And it requires like a really good understanding of the current context to compress the context well, right? So it's like a double-edged
Not
sword.
just compressed versions of past context.
Yeah,
necessarily.
that's right. And
Yeah.
once we get like 6 compressions deep, like once you see Claude Code do its 5th compaction, right? Like stuff, important stuff is gone. Like, you know that to be true.
Yeah,
And it makes sense. We can't grow it forever, but also we need to lose something to shrink it. So the pros are obviously that compressed context is less context, and we know that LLMs do better with less context than more context. Even when they tout extremely long context lengths, a lot of models are okay at it. Then file systems for me is something that is not infinitely better, but it is a form of offloading context, right? So just like we have, for our model weights and transformers, we have like CPU offloading, where we can some computations, whatever, just handle on a CPU. We don't care about on GPU, right? and just give us whatever the result was. Like for me, file system is that context offloading. We're not getting rid of it, so we're not losing information. We could go back to that information if we needed to, and we can search through it really well. And the cons are that there's a lot of operations involved now, right? So instead of just like everything's in context and we're chilling, it's like, okay, I need to use like 6 tool calls to find the right file, then read through it, then determine what are the important pieces of context, blah, 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 right? So we're going to see a higher volume of smaller calls, which is a big hit to latency. And what we'll see in one of the notebooks is like the approach is slower if you use something like RLMs, but it's only slower at those small contexts lengths, which implies there's some kind of balance here, right? There's some kind of tasks that are better suited for non-RLM approaches versus RLM approaches, which I think the paper outlines well.
Okay. So sometimes it makes sense to just offload stuff to a file system that you're going to go back and you're going to reference often. And maybe the first cut is something like, an agentic RAG solution where you're just saying, hey, go figure out what to bring back and bring it back to me. And then if you end up doing a lot of it over and over consistently in just the same way, it's like, well, maybe I'm gonna actually compress this down to like a classic RAG system where I'm going to remove the agency from it because I already know what I need half the time. And then more performant. But in spaces where it's just growing like a weed over time, that's where we're going to find. So there's going to be a crossover point, right? Where we're going to move that I would keep in mind too. Language models.
Yeah, we say this a lot, but like I actually think that we will see systems like trend towards back to more classic systems as we discover what it is that people are using them for, right? Like if I have a finite pool of knowledge, even if that knowledge grows at a decent rate, right? Like at some point I'm going to know that like 80% of my customers are asking questions about like 4 documents, right? And like I don't need to go through this whole rigmarole for those 4 document related queries, right? Like this has always been my take on AI, which is that it solves a zero data problem, right? Like that's what it has been doing for us. That's what it's continuing to do for us. I think ultimately what we're going to see is as you begin to understand the distribution of queries, you're going to say, well, this stuff can just be RAG. Why the hell do we need these crazy systems for this, right? This stuff though, or anything that's not in this very particular box, let's throw the world at it, right? And so these kinds of tools though help bridge the gap from like I just started to I have 10 million queries that I can look at and make a determination.
I just started, and I want to get away from the classic stuff. I mean, this is a research day, okay? We got to stay big hype today. But like, I do think that there is a very interesting point you're making, and that enterprises should think about, which is, I've got all this data. I don't know what to do with it. At some point in the future, I'm going to be like, oh, this is all my data, and I kind of know what I'm doing with it. And as new stuff comes in, this is what I do with it. In that space, it becomes more boring. There's less exploratory data science. It's more of an execution problem. But here, as we, if we need to generate insights from the extremely long context, maybe this is the ticket. Okay. Thanks, Wiz. Let's go ahead and continue the discussion of RLMs and context folding here. A different approach to file systems and summarization is context folding. The goal is to have a continual growing rollout while managing the context window itself instead of external files. Now, interestingly, this is also compatible with file-based scaffolding. Just because I'm managing the stuff inside doesn't mean I can't also have an external set of files. So as we see yet again with the new tool, it's not that it's fundamentally different. It's Another tool in the tool belt, both and is the solution. And the reason for this is, as we've mentioned already today, the RLM looks exactly like an LLM to anything that's interacting with it. Okay. This wasn't the first idea of context folding, the RLM. In fact, 2 days before Alex and Omar came out with the paper on October 15th, the blog on October 15th, this paper called Scaling Long Horizon LLM Agent via Context Folding came out. We introduced context folding, a framework that empowers agents to actively manage their working context. An agent can procedurally branch into a sub-trajectory to handle a subtask and then fold it into completion. Oh, okay. That's pretty straightforward. Basically, it's branch development. And what a straightforward thing to let agents start doing, where we're diverging from the main line of development, continuing to do work without messing up the main. And so the agent is basically actively branching its rollout, returning from the branch, while within the branch, it retains the full previous context. Once it returns, it chooses a summary. So this is still a summarizing approach here of the branch to keep in the context window. So there's all sorts of levels of this idea of context folding, and this self-chosen summary should make a lot of sense to you guys, but that's not the only one. That's context folding from the original paper. We also have this idea, check this out, 2 weeks later, just stuff popping off in October, Agentfold, a novel agent paradigm centered on proactive context management, inspired by the human cognitive process of retrospective consolidation. What's that, you ask? As alluded to earlier, this is where our memories are strengthened after we sleep, where we might say short-term memory becomes long-term memory. And I know what you're thinking. Gosh, how can I learn more about agent memory? Well, we've got you covered. We covered it just a few weeks ago on this very channel. So let's talk about Agentfold. This is where every one of the agent's actions produce both a result and summary, again here, of the action and the reasoning that led to it. These summaries can be hierarchical, consolidating the lessons from multiple actions into a single point, or retaining per action summaries. But it doesn't stop there. And this is the third one that we'll cover. That's not RLMs. This is called, probably the worst name, Agentic Context Engineering, ACE. But the thing that's interesting about ACE, and note, it's from October 6th, earlier. It's a framework that treats contexts as evolving playbooks. This is maybe the key insight from ACE. And as Prime Intellect and Sebastian tell us, it's a 3-agent system: generator, reflector, curator. And it's that evolution from the paper, the ACE paper. Contexts should function not as concise summaries, but as comprehensive, evolving playbooks. And so Prime Intellect said, you know what? We're looking at all these. RLMs is the best. It's a huge focus area for us this year. And here's what we're going to do. We believe the RLM needs to actively manage its own context. Remember what we heard from Alex in the tweets and the team at MIT. We should let the LLM itself decide how to best poke around. In short, we should give the LLM agency over its own context. And we shouldn't be scared to do it. We should let the context machine look through its context to get better context, no different than tool calling today or than data science generating insights for us. This approach is more in line than the other three approaches we just talked about, than the ones presented before, more in line with the bitter lesson. It enables training directly with the RLM scaffolding, training directly, getting better and better so we can do learned context folding. And it never actually summarizes, so there's no loss. Instead, it proactively delegates. And of course, if you know Prime Intellect, you know that they're all about that RL. And so they're going to now start teaching models to own context end to end through RL. And they believe that's going to be the next big breakthrough, the next major paradigm shift. Perhaps RLMs did bring about the next milestone. Shout out to Alex and Omar. Did they, Wiz? Is this truly a new paradigm, or are they just LLMs and we're just doing the same stuff as we've always been doing?
They're just LLMs. We're doing the same stuff we've always been doing. I mean, it's like I said, it's clean. It's it makes sense. It's good formalization, but it's not really like there's nothing inherently new or different. One of the comparisons that I see them make a lot, them being the paper writers, is that RLMs are being called RLMs in a similar fashion to LRMs, large reasoning models, right? Where there was this kind of shift in the way that the model was being used. And I think that the LRM distinction, so these are models that now do this new thing, right? Makes a lot of sense to me, because before they didn't have thinking tokens. They didn't generate for 15,000 tokens before producing a final response. So yeah, I mean, end of the day, that distinction made sense to me. Yeah. RLMs is just like, it's an agent, right? Like, it feels very agenty. It doesn't feel. It's the LLMs doing the same stuff it's always been doing, right? It's calling tools. It's using tools. It's reading the output of tools. It's not like a brand new thing. It doesn't change how we use the system. It's like putting a name on an agent as opposed to the language model itself. And so that's how I feel about that one. It's not new. Is this a extraordinarily useful pattern and a very clean academic presentation of it? Hell yes.
Okay.
Strong yes.
All right.
But it's just LLMs.
Okay, but you mentioned LRMs, right? And like the language they're using is piggybacking right on that, right? Yep. General purpose inference time scaling. Hard to disagree that it's in that same space, but does it deserve its own name? Is it going to get like a thinking designation or a recursive designation in ChatGPT? Unlikely.
Yeah, I don't think so.
Okay, Todd had a fun question. How did this go? Gangbusters. Then, if it's actually not, I mean, besides Omar really knowing how to play the X game, like what's your take on this?
I think a lot of labs picked it up very quickly. I know that some of the smaller burgeon neo labs is the term that I've heard to describe them. I love that. These neo labs picked it up, but most importantly, I mean, it came out right at the start of 2026, and it planted a flag saying this is what this year is going to be about. I think it was a very the title was crazy good.
Yeah,
I don't agree with the
yeah.
idea that there should be called recursive language models because it doesn't describe, it's not self-descriptive, it doesn't match the intuition for what the thing is. So large reasoning models, they reason, that's what they do. Recursive language models, they use REPL, right? So it's like, okay, that's cool, I guess, but it doesn't fit. But it was like clickbait, right? It was like the best kind of clickbait. Non-derogatory clickbait, to be very clear. And I think it got a lot of people to read it, and then it got a lot of people talking, and then it got a lot of people saying we've already been doing this forever. And then the paper authors are like, yes, exactly. We just put it into a paper. I think as well, many people over the winter break discovered Claude Code and Open Code and Codex as useful tools. And the way that they do a lot of the shopping around context is similar-ish to this, right? With subagents that have access to file system. It is it's something that was like on people's minds, and then the paper blasted out. So that's why I do also think that it's a great landmark paper, right? To say that 2026 probably is going to be very heavily influenced by these kinds of patterns, where we say, why are we just shoving context into the LLM without letting it help decide what context is best for it, right? So
it sounds like you're saying it kind of captured the zeitgeist, almost in a paradigmatic way here. Okay, all right, let's go ahead and get into the tutorials, Wiz. You got some banger tutorials. We got to make sure we got time for them. We got RLMs. We got 2 different ways. Let's hand it off to the Wiz for today's double demo, where we got RLMs with the classic GitHub repo and RLMs through DSPI.
We're going to schmoove through these demos, folks, okay? Because we don't have infinite time. But what we're going to do is we're going to look at very briefly the RLM library. So this is from the paper author. There's lots of copy that you can read if you want to read it. But the big thing is that we're going to clone the repo. We're going to make sure that it's been installed. And then we're going to add one of our API keys. And then we're going to download all of the War and Peace by Leo Tolstoy, which is, it's a lot of characters. So it's like 3 million characters. Maybe it's around 800,000 tokens. So it's a big boy. This is the idea, right? Then we're going to set up our logger, because there's a really cool visualization tool. And then we're going to set up our RLM. Now, you'll notice setting up an RLM is pretty straightforward. We use the OpenAI backend. We have some backend keyword arguments where we're just going to use GPT-4o mini because we still have to process a lot of tokens. Okay, so this is something that I have discovered with using these kinds of tools. Sometimes the tool says, I need to look at all the text. And so the print all the text is what happens. So, sometimes these tools can kind of blow the budget a little bit. Then we're going to set up our environment as local, since we're going to be using local. You can do this in sandboxes, through Modal, through Prime Intellect. How many levels deep can we go? So this is like, can our subcalls call subcalls? How many iterations we want to accept? These are just like useful cost limiters, right? And then we can see this beautiful little UI. We're going to have a simple query, which is print me the first 20 powers of 2, each on a new line. And then we get the iteration, right? Let's start by examining the context, blah, 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 blah. I'll print the context. Context is print me the first 20 powers of 2, each on a new line. The context variable contains a request to print me 20 powers of 2. To fulfill this request, I'll generate the first 20 powers of 2 from 2 to the 0 to 2 to the 19 and format and print on a new line. REPL, powers of 2. 2 to the power of I for I in range 20 from 0 to 19. output's going to be joined by new lines, and then I'm going to print the output. And then look at the code execution. Oh, look at that. I have successfully completed. You see the idea, right? It's a back and forth between this and the output. There is a name error in the actual library that I've run into, which crops up occasionally. That's what it's like on the edge. Sometimes your final answer is just the word output. But if we look through the logs, we can see it did the thing. So we're happy. Then we can look at analyzing War and Peace. Analyze the structure of War and Peace. How many books or major sections have it? Identify the main characters mentioned most frequently. How does the narrative focus shift from beginning to the end? Now, this is interesting to me. So what we do, first of all, is examine the context variable, and then we're going to look at the context, and it's all of War and Peace, right? It's just looking at the first 1,000 characters here, which is still a lot of characters. And then we're going to go ahead and count the number of book occurrences. Now, what's interesting here is that we do all this code back and forth, back and forth. Look at all of this, back and forth, back and forth. We love it. It's looking at a bunch of stuff. It's repling a bunch, right? And okay, oh, look, all of this. We're going to get such a good answer, I bet, right? With all of this work that's being done. Oh my gosh. So total number of books is 4 major books. That's crazy because it's super wrong. Main characters, also super wrong. Narrative focus, also super wrong. This, in fact, answer is entirely wrong. It is totally incorrect. But it did so much work. And this is something that I think is important to keep in mind with these kinds of approaches, which is that they're still limited by how good the LLM powering them is, right? So this is 4.0 mini, and it did kind of like a garbage job, right? It really failed spectacularly. But I thought it was interesting, so I left it in the example. You can't just throw RLM at everything and expect to get magic results back, right? So this is something that you have to work on and still think deeply about. But it's a cool approach. Now we're gonna look at the DSPI or DSPI implementation, which it is much cleaner. No disrespect to the code written by the paper author, but the DSPI version I think is a more familiar format. So same thing as before. We have to set up our keys. We're going to set up our language model to still be GPT 4.0 mini from OpenAI for our DSPI LLM. You could also use Anthropic if you wanted. We're going to use this time the complete works of Shakespeare. So a slightly different big collection of text. There's still 5 million characters in the complete works of Shakespeare. So it's not, we're not slacking or anything. We're going to set up, of course, our DSPI signatures. I'm not going to talk too much about this, but the idea is the signature is describing kind of what the program is going to be. In this case, it's context and query should lead to an answer. In other cases, for a structured signature, we have context and query should lead to a summary, key quotes, and conclusion. And then domain-specific literary signature is text and question should lead to analysis, evidence, and themes. This is like DSPI or DSPI language for how to write a DSPI program. To use RLM, we simply import RLM and then we use it. We have the same cost control. Knobs here for DSPI. We can try with small context, right? Simple context, the secret codes are alpha, beta, gamma, delta. Remember, the master code is the sum of alpha and gamma, and we can ask the RLM with our simple context, what is the master code? And we get this, you know what I mean? You get the whole thing. You get a back and forth, call in the repo. At the end of the day, boom, we get the response, right? We get the summation of these two things. Excellent. Then we can do bigger things, like count how many times the word love appears in the complete works. This, to me, is the example that best demonstrates why we should give a hoot about this approach, right? Because this is a question that I would typically never ask, especially RAG, right? Dr. Greg and I have I've talked extensively about how these kind of aggregating questions are just not what the LLMs are good at, right? This isn't their strong suit. But you know what is good at it? Python. And so you literally just can you can literally just count using Python how many times the word love appears in the complete works of Shakespeare. And then all the other stuff that we said is still going to happen, but the demo's already blowing by a little bit. It's 1,339 times that love appears in the complete works of Shakespeare. Incredible. And perhaps unsurprisingly, Romeo and Juliet with 622 occurrences is the most. Look at that. You know what I mean? Like this to me is crazy. This is an insane result. If I asked this question at Jeopardy, right, like or Claude, it'd be like, I don't know, brother. I can't even fit all that in my context window, guy. And with the RLM approach, hell yeah, I know exactly how many times the word love appears. And this is the power, right? Like it's a simple example, but to me it demonstrates the idea that allowing the LLM to learn about the context and understand the context by poking around with it through that code lets us get these really great examples. And we get 2 quotes, which is great. You know, but soft, what light through yonder window breaks? Is it the east and Juliet is the sun? Wow. What a good quote about love. Thanks, RLM. Okay. All these notebooks in full are available on GitHub, so please play with them. But the idea is straightforward from here. We just do more questions and then talk about how you can, I'm just going to scroll a little bit. Please excuse the scrolling. Talk how you can implement custom tools, right? So just like we would normally do. Anyway, long story short, this approach is useful for especially some kinds of queries. But you have to keep in mind the reality that the LLM that is running the show still needs to be pretty decent. And something that is also explicitly outlined in the notebook is that you can actually choose to have your main LM be different from your sub LM. So you can have different models doing this sub querying versus the main querying, kind of like what we'd see in a hierarchical agent structure. With that, I'm going to pass you back to Dr. Greg. But before I do, I have to remind you to like and subscribe and ring the bell notification because we're here every Wednesday, every single Wednesday this year. A total of 52 events across the whole year. Let's go. Okay, back to Dr. Greg.
Okay, quick question. We're going to have time for one question today, and I want to get to Raphael's here. How do we know when it should stop recursing?
Oh, we don't. No, absolutely.
We let it decide.
It does, right? Like this is the we're hands off at that point. Once it's in the first layer of recursion, whoa, we're letting RLM take the wheel here, right? Like there's actually, hang on a second. We should look at the prompt. Let me. I know that we don't have time for this.
Letting LLM take the wheel. That's kind of a nice little theme that gets us into next week.
Oh yeah,
and Ralph Wiggum that we'll be covering next week. So join us for that one, everybody. Okay, you find anything in the prompt?
I just want to show the prompt real quick,
okay.
Because I do think it's interesting to look at, because at the end of the day, this is like RLM is dope, but at the end of the day, like this is the instruction for RLM, right? You're tasked with producing the following outputs given the inputs. You have access to a Python REPL environment. Write Python code, it will be executed. You'll see the output, then write more code based on what you learned. This is the iterative process. Available variables. Important. This is iterative. Each code block you write will execute. You'll see the output, and then you decide what to do next. Do not try to solve everything in one step. Explore first. Iterate. Verify. Use LM query for semantics. Minimize retyping. Submit only after seeing outputs. Like this is all we're saying is, yo, dog, could you please call this REPL tool as you see fit over and over again until you're done, right? Like that is the essence of RLM. This is the prompt. Right. I just think it's so illustrative to understand.
Prototyped it with this simple prompt.
This is the prompt.
This is it.
This is the whole thing. Right.
This is how easy it is to change the entire game for everybody today.
Yes.
Yeah.
Okay,
unbelievable.
thank you for
All right,
thank
you,
you for that.
All right. Thank you, Raphael, for the great question. It's time to wrap up. Thanks for your expertise today, my man. Okay. In conclusion, RLMs, they're just LLMs. They use REPL. They're great for extremely long context, and they don't use summaries, although we still can with external file systems. It's something like LLMs that use Jupyter notebooks. It's something like LLMs that are data scientists. Watch out, data scientists. If you're a little sketched out about that, you probably should be. The best yet method of context folding. Let's see what else 2026 has in store for us as we continue the context. If you have other questions, please throw them into the YouTube comments today, and we will get to them this week. Thanks again for joining another weekly Wednesday workshop with AI Makerspace. We are on a mission to create the world's leading community for people like you who want to build, ship, and share production AI applications. We got people around the world building, shipping, and sharing all the time. Jump into Discord today and start building, shipping, and sharing with them. The way that we plan to get there is to create the industry standard certification for people who want to become AI engineers. So I know a lot of you guys are very advanced. A lot of you guys are already certified by us. But if you're watching this and you know anybody that might be able to benefit from getting up to speed very quickly, out to the edge, getting that new AI engineer job, which is the hottest job on LinkedIn heading into 2026, point them towards the AI Engineering Bootcamp. V1.0 is going to be released April 7th. And if you enroll now, especially with a referral, you can get early bird and referral discounts. We'll put our discount policy in the notes on the YouTube live stream today. And if you want to know what this is kind of all about, check out our LinkedIn today. We had 23 people building, shipping, and sharing the very first week of cohort 9. I recommend you get out there and follow each and every one of them because they are likely to get on the path and start seeing some success very quickly, maybe as quickly as these RLMs. And with that, everybody, thank you for joining us for another Weekly Wednesday. We'll see you next week talking Ralph Wiggum. We hope to see each and every one of you back here. Same time, same place, all 52 weeks of the year. Until next time, keep building, shipping, and sharing, and we'll do the same. Till next Wednesday.